So the chapters in our read, watch, and listen are dealing with reading a WPS, which is called a welding procedure sheet. Now it's a pretty long chapter and it's pretty tough reading, so I wanted to do a video that kind of just breaks it down into easy to understand language of what do I really need to know when I'm on the job. What do I need to know about WPS that enables me to do my job and helps me do my job better. The easiest way to think of a weld procedure sheet is to think of it as a recipe, a weld process sheet. It can be called either one. Think of it as a recipe. That's a recipe for making a weld. So in this example here, it's like, okay, if you like cooking, say you come up with a recipe for a really, really good cake. You're like, yeah, it's a great cake and it's a perfect recipe. Now the thing is, okay, but what about if I need to go from an amateur to a professional and I need to make that cake not just once, but maybe I need to make 100 of those cakes like every week, and it's got to be exactly the same every single time. So that's kind of the same dilemma here. You can weld up something, but then what if you got to do it again? Well, you don't want to waste time or material fiddling around with your settings to try and come up with the same settings so everything works out perfectly. The best thing is to write it up and make a recipe for it so that anyone can read the recipe, put the settings on the machine, use a particular welding rod, and the weld comes out perfectly every single time. So that's the goal here. The goal is repeatability so that either you're making many of the same thing and they need to come out perfectly, or you're doing really, really critical work like things that are high pressure, that have to support a lot of weight, critical infrastructure that cannot fail and it has to pass rigorous inspection. You want to come up with a way that you can ensure that it's going to come out right and pass every single time. So it's really about writing it down and making it repeatable for anybody. These 2 pages in front of you are a sample weld procedure sheet, and there is no standard form for this kind of a sheet, but there are things that need to be on it. So every company can really write up their own one specifically to what they do, but there are things that are common to this weld procedure sheet that all of them should have. And we're going to go through all these sections piece by piece and explain what they are. And if you were in a shop or business that use these things, this is what you would be handed, and this is what you'd be expected to understand. So we're going to go through this step by step and learn what it means to us in the real world. So this is the top of page 1, and in the highlighted red section, you're going to see a lot of stuff that looks very, very familiar to you, and it's kind of the same things that we see in the title box on a technical drawing. So we have the organization's name that created this thing. It's Papa Welding Fabrication, and you can see who wrote it. You can see what the number of this sheet is or drawing, the date, and you can also see revision as well when the revision was done. And there's also supporting PQR, and that's performance qualification record. Now, a very important thing here is that when you have a recipe, you need to be able to repeat this thing. So you need proof that it actually works. So the PQR is actually someone else taking this recipe for the weld, doing it and proving, yes, this actually works and it's approved. So that's what the PQR is. A lot of these acronyms can be confusing, but the PQR is supporting evidence that, yes, this actually works. The next section below is telling you what type of welding process it is. In this case, it's an SMAW, shielded metal arc, a stick process. Type manual. And you can see under manual it says automatic, manual, machine, or semi-automatic. So that right there tells you what kind of process is going to be used and how. The section below that is joints. So we know what kind of welding process we're going to be using. Now we need to know what kind of joint style and type that we're going to be making for this weld. So the joint one tells us in their single bevel weld only, and the root spacing is 1/4 inch, and there's a backing bar. So and type of and a strip. So it's very important that it tells us exactly what type of joint is being made, and that this sheet only applies to this specific joint, and metal and welding specification only works for one thing. So it's very important here. And these always include a sketch or a drawing of what the joint looks like. So what you see is what you get. Now that we know what kind of welding process we're using, what the joint looks like, now we need to know, well, what's the base metal? What are we welding together? So the next step in here, base metal has some things that we maybe haven't seen before. There's a P number, a group number. Now these are for different codes. These are ways of classifying different types of similar metals, like what things can join to other things successfully. And they have P numbers or group numbers. And you can learn more about that in the reading. And if you do work with different metal codes in welding, they'll tell you more about that. Now, some of these things aren't filled out because they don't apply, so they're just left blank, or it says NA, which means not applicable. Thickness range. So this circled in the blue is very important. It tells you that the weld thickness here for the base metal is 1/16 through 3/4 of an inch, which is a pretty big range. So a very important thing is many of these weld procedure sheets will cover a wide range of things, because let's say it says 1/16 and that's all it says. That means you can only use the sheet on 1/16 thick material and nothing else. So usually there's a wide range, so it's allowed to use on a wide range of metals. Otherwise, you'd have to draw up like a dozen of these different things. And it's easier to just have one that covers an umbrella of different sizes. It's a little more convenient that way. Now we go into the back of the form itself. And the first thing we look at is positions. So we've got what type of weld we're doing, what kind of process we're using, stick, what kind of base metal and the thickness of the base metal this applies to. And now the next one is, well, what position is this in? So this one says horizontal only. Well, so that means here is that you can only use the horizontal position. You can't do vertical, you can't do overhead with this one, only horizontal. And it also says welding progression, and you can see up. So you cannot weld downhand, only vertical up in the horizontal, only up in the horizontal position, and that's it. So that's an important thing. You can only do what what this sheet says, and only under the conditions it says. Now, if it's necessary, it'll tell you what the preheat is. Now, here it says 50 degrees F is the minimum temperature, which is kind of like saying, well, room temperature. Now, in some cases, depending on the alloy, you may have to preheat to say, let's say 300 degrees. If that were the case, then the minimum would say you must heat the metal to 300 degrees before you can weld on it. So this is an important thing to look at, and it's all depending on what type of base material, what kind of welding filler rod is being used. And again, since it's a recipe, you have to follow this thing. It's kind of like on recipes where it says have all ingredients at room temperature. If they're not at room temperature, then that throws off all of your other um, temperature for your oven, time, and everything else. So these are very, very important things. So if you have preheat, you also have post-heat. But in this case, it says temperature range, time range, other, it says not available. So in this case, the base metal that's being welded does not need any post-heat treatment. So it says NA for not applicable. If it were like a high carbon tool steel or something that's being welded, well, then it might say it has to be post weld heat treat at a certain temperature for a certain time, and it would give you those instructions. because we are doing a stick welding procedure, we're not using any gas. So over here, the categories for the type of shielding gas being used has NA for not applicable. If we were MIG welding this or TIG welding, then we would have to fill this out, and we put in what type of gas it is: argon 7525, 98.2, 95.5, 90.10, whatever, and the flow rate, which would be your cubic feet per hour. We'd have to get with those specifics would be given to us so that we can set the machine, and we wouldn't have to be fiddling around with that to figure out what works right. Now that we've got down what type of weld process we're using, what type of base metal we're using, any condition that need to be set up on the machine before we start, now it tells us next here how many passes we have to do and what type of rod we're using. So we can see here the first pass is shielded metal arc, which is stick, and we're using a 6010 rod, 1/8 inch in diameter, and it tells us DC and the amp range 80 to 90 for the 6010. And then next for second and later passes, which is your cover passes, it's 7/18 1/8 inch, and the amperage range given is 80 to 120. So that would give you where your amps should be, and you must keep within those. So it says you can be between 80 and 120. You can't be less than 80. You cannot be more than 120. You've got to be there. And now inches per minute is 3 to 15. So that gives you a pretty wide range of how fast you have to go. Because this sheet is set up to be applicable to all the possible welding processes you might be using on a job, this has a section here that says amps and volts or power energy range should be recorded for each electrode size, position, and thickness. Because we are using shielded metal arc, we don't need to fill this in. So pulsing current, tungsten electrode size, mode of metal transfer, which is what we'd be having to put down if we're using a MIG process, like um, short circuit, globular, spray transfer, something like that. None of those are applicable here, so we don't have to fill anything out. But if we were using those processes, or those were specified for this process, then this would be filled out for us, telling us which settings to put it at. This part down here is the how we're actually going to do it. So this is technique, and this is an important thing to look at because this tells us once everything is set and we do begin welding the part out, this is how they want us to do it. So on technique, you can see the first thing is string or weave. Bead says string or weave not to exceed 3 times diameter of electrode. So that gives an important parameter. And of course, that's something that we've reinforced in class over and over again because it's really a common standard for when you're stick welding. So it spells it out right here. Now, orifice on the gas cup size, that's a TIG welding specification or MIG welding, but not applicable. Now, it says all forms of cleaning are acceptable because there are some cases where certain types of cleaning would not be permitted or only one type is permitted, and that would be spelled out here, like say no grinding is permitted or maybe no chipping, and that would be there. Back gouging is not allowed. Okay. If you go down to peening, it says no peening, chipping slag is not connected to peening. Now, peening means hammering on the weld with a ball peen hammer. There are some rare cases where that is done in order to reduce built up stresses in the weld. It's very rare, but peening is hammering on the weld while it is cooling down, and here it's saying don't do that. But you may chip off slag, and that's okay. So that pretty much sums up all the material that you'd see on a typical WPS sheet. So let's recap here. So the goal here is that a WPS would be written up so that anybody welding a particular part would be able to set up their machine and be able to execute welds that would pass inspection and be successful every single time. Now, in your career, you may or may not see this. This is very common in any job that is government or military related. Any kind of job that's doing structural work like bridges, buildings, anything that's load bearing or contains pressure. It's not something you would see in small shops where like every job you're doing is different. You're not repeating stuff over and over again. You're doing things that aren't really structurally critical or can fail, explode, or cause massive damage. So it's something, depending on the industry, you may do that. Now, in many cases, these refer to codes. And in the chapter in the book, when they talk about codes, codes are voluntary. They're different from laws. It's a very important thing to keep in mind. Codes are recommended best practices. Now, they come about because people have really worked hard to say, well, if it works, maybe we should write it down. And let's establish rules to ensure that things are successful, they're safe, and they work and they can be trustworthy. So all codes are a voluntary thing that companies can choose to follow. They can choose to join different organizations that write and maintain these codes, but they're not obligated by law to follow any of these things. So that's an important thing. That codes are different from laws. Those are two different things. All right, but many companies use WPSs and PQR sheets just because it makes it much more efficient. It's good to make things that are trustworthy and that are strong, that don't explode, don't kill people. And if you're making lots and lots of stuff, it is not efficient to reinvent the wheel every single time. Now, in the lab, at this point, it's a good point of practice for you to keep a small notebook. And when you have really good settings that you're working with, you should write them down. That's one of the reasons why I gave you all the settings for the box project. I spent some time working through settings to find what worked really, really well, and I wrote it down and said, hey, use this because it works and it's going to give you a really good weld. You don't have to waste time trying to reinvent the wheel here. That's sort of the basic beginning of a WPS right there, ensuring that anybody who uses it will be successful. So I hope this helps, and make sure you read the accompanying chapters, and this will illuminate it a little more.